Seeking English S.A.T. Workbook, page 388, problem 2, follow-up. At some point I might reshoot all these videos. In the meantime, they have plenty of value in them, provided you are willing to put up with this glare, which after a year, I'm still not able to defeat for logistical reasons, let's say. Okay, this is a follow-up to the previous problem, in which I didn't think I was going to have enough time to stick everything on the board, and to make sure that I get everything correct on the board to explain it for the video takes some time, and it looks a little messy, but to squeeze just a little bit of extra value out of the problem, I think it's worth it. What I showed you in the previous video, that's enough value for one video, but this problem has a little bit more to it. Things that I mentioned in the previous video, I did not explain them in the kind of detail that I could have gone into, but no, I thought I should save it for a second video. This is the second video. You've got a mountain peak here, and you've got some smaller mountain peak. That was in the previous problem, and the relationship is that the smaller mountain is 20% shorter than the taller mountain, and I mentioned that 20% of the larger number is not 20% of the smaller number. Okay, hopefully that sounds like an obvious statement to you, but I see students getting it wrong again and again and again, so I'm not bringing it up again just to make it absolutely clear. What do I mean by that? Well, if you take these 4 candidates for that smaller mountain and you multiply each of them by 1.20, you get these 4 different numbers. The correct answer, if you take this number and you multiply it by 0.8, which is 20% smaller, you should get this number, 4956. Okay, and so this number, each of these numbers differs from the correct calculation by some number. And this is that number. This number is off by 90, this one's off by 6, this one's off by 44, this one's off by 199. So the correct answer, as I said before, was letter B. Great. Well, but teacher, what if it doesn't affect the answer? Well, if it doesn't affect the answer, it will only not affect the answer incidentally. It will affect the answer on this question, and if by chance it does not affect the answer on the real test, you will be relying on luck. And I'm not teaching you to rely on luck. Okay, I wish you luck, but I have to do better than wish you luck. Okay, so what we have here is I took also this. If you look at these numbers, okay, I made this the error for the smaller mountain in terms of the correct calculation from this number times 0.8. From the miscalculation here, okay, we have errors between these calculations up at 1.2, okay, between this and that, and I had to stick them over here. With the glare and everything, I don't know. You want to come in here and fix it for me? Fix it for me. I don't think you're going to fix it for me. Okay, so in this case, if we do the problem correctly, we find that's the smallest margin, and I'm going to come back to that. If we do the problem incorrectly, we find this is the smallest margin. So we're going to pick the wrong answer if we do it. So the relationship is not it's not scalable, right? For lack of a better term in this case. Okay, it does matter, or it probably will matter on the test whether you do the thing correctly or not, because 20% of the larger is not 20% of the smaller. Not everything stretches in the way you want it to. I'm coming back to this statement though. With this 4956. As I said in the previous video, there might be a temptation to think, well, I have to round this 6 either up to a 0 or down to a 5. That you wouldn't. The idea is I wouldn't round it down to a 0. Yeah, intuitively that's wrong. But it doesn't matter what the rounding thing, which I mentioned in the last video, and I didn't explain why that's not really the best way to think of it. I actually called it rounding. You shouldn't be rounding. You should not really be thinking of rounding the 6 up or down. You should be thinking in terms of what the difference is between this number and these other numbers. A consequence of that is that as a way of reporting this thing, you will appear to be rounding a 6 downward to 0. Okay? Please If this problem is as interesting to you as it is to me, tell me. If it's boring, you can tell me too. Tell me something in the comment section. There's a lot of value in this problem, in addition to what I showed you in the first video. And I'm trying to show you that value here. Okay, there's a lot to see in this problem.